JAMB 2026 candidates, you are welcome to today's lesson, and today we are looking at calculations under Faraday's first law of electrolysis. So you should know that this question cuts across both physics and chemistry. So as I'm treating it here on physics, I've also treated it in chemistry. So it's the same question that you are going to see in physics and chemistry, the same question pattern. All you need to do is to what? Do the needful, get your correct option, get the correct answer, pick from the option and leave there. All right. So if you need last minute preparation plan, you want me to help you, you have not been preparing, you are a last minute preparation candidate, or you need any of my material, my short lesson notes, straight to the point, everything, all road leads to my what? My WhatsApp. Okay. Send me a message. Let me help you. Okay. I've been helping students for ages. So what? Send me a message. This is my what? My WhatsApp number. No lose guard though. So the question we have in front of us here, JAMB must repeat question 1. The question reads, calculate the mass of magnesium that would be deposited by 8 Faradays of electricity. Mg equal to what? 24. What is this Mg? This is actually the what? The molar mass of what? Magnesium. All right? The molar mass of magnesium. So now looking at the options, all the options are represented in gram. All right? All the options represented in gram. So since they are asking us the amount of magnesium, that's the mass of magnesium that will be deposited by 8 Faraday. This is trying to tell us, this is the first law of Faraday. Okay, Faraday's first law of electrolysis. We state that the masses of an element discharged during an electrolytic process is directly proportional to the amount of current passing through it. So Faraday's first law, Faraday's first law, his first law of electrolysis, it states that mass M, okay, mass of an element discharged is equal to what? ZIT. This is the amount of current passing through it. T is the time, and Z is what? The electrochemical equivalence. Okay, or we can also use this formula. It's also the formula of the Faraday's first law. All right, M, which is the mass, is equal to Q M. If we are working with molar mass over N F. All right. Okay, so this F is for Faraday's constant, this Q is for quantity. We are going to do that. Okay, let me just quickly write everything under here. All right, so that may I not forget. Okay, where in this formula M is equal to mass deposited, mass deposited, the mass of the metal deposited, and it's usually represented in gram. Okay, then Q, look at it. Q, this one, Q is equal to, remember we have two types of M. We have capital letter M and small letter m. Okay, small letter m is for mass, that's this mass, that's this mass. Capital letter M is molar mass, that's this one. Okay, then Q is what? The quantity. The quantity of what? Of electricity. Electricity. Okay, that's the quantity of electricity you pass through the electrolytic system. Okay, it's usually represented in what? C or F. What is C? C is coulomb. Okay, coulomb. Okay, or Faraday. Okay, why what? Which other one do we have? We have M. M, which is, I told you before, that is what? Molar mass. Molar mass. Okay, molar mass, which is usually represented in gram per mole. Gram per mole. All right. Which other thing do we have? There we have N, and this N represents what? The what? The valency. The valence. Okay, the valence electron. Okay, valence or number of electron. Anyone? Number of electron. Okay, so this valence or number of electron is the electron discharged by the what? By the element or the metal. Okay, electron, and that electron discharge is usually the valence electron, the amount of electron found in the outermost shell, okay, of that element or of that metal. Okay, we have the final one here, which is F. F is equal to what? Faraday's. F is equal to Faraday's constant. Okay, Faraday's constant, which is equivalent to 96,500. What is this? It's not coulomb. Coulomb per mole. All right, coulomb per mole. All right, so this is the formula. I don't explain what everything stands for here. So we are going to do this calculation in the next side of this paper. So before we do that, when I go straight to the other side of the paper, I am going to write out all we were given there. Okay, so put this thing inside your head now. All this thing we will write for inside your head, because we are going to use them there, and I'm just only going to represent it. All right. So here they gave us 8 Faraday here. So this F now, this F, now be 8 here. Now we go write for that side what they give to us. They also give us mass of molar mass of magnesium. See the molar mass where they give us. Okay, what they want to give us again? Okay, those two. So make we go right hand for the other side. So continuing from here, giving. Okay, they gave us what? They gave us molar mass of magnesium. Molar mass of magnesium equal to 24 gram per mole. They also gave us what? They gave us Q, which is 8 Faraday. All right. That be the thing where they give us. Remember, they ask us to calculate the mass. Mass equal to question mark. Mass of magnesium, discharge. Okay. So the first thing to do when they ask you all these electrolytic question or question involving stoichiometry, okay, anything involving stoichiometry or electrolysis, first of all, write out the ionic equation, okay, and ensure that the equation is balanced. All right. In the question, they told us that how many mass of magnesium will be deposited by 8 Faraday of electricity. So first of all, we will write the equation mg, which is magnesium. Okay, what will be the valency of magnesium? Plus 2. Not valency, valent electron is 2 plus 2 plus 2 electron what? Electron loss. It loses 2 electron to what? To discharge. It loses 2 electron during the electrolytic process to be discharged at what? Magnesium metal. Okay, so magnesium loses, is a reducing agent. It's a metal. It loses 2 electron and becomes what? A metal. It is ionic form here. It can't lose 2 electrons, can't become what? Metal. It's not discharged as metal. All right. Therefore, this 2 electron is not that n is equal to 2. This 2 electron. So it's the what? The valence electron, the electron that was transferred, that was lost, okay, during the oxidation process. All right. Valence electron or number of electron, anyone. So when we now come here, we'll now put it n is equal to what? 2. Easy, shikina. Then what are we going to do now? We'll now apply that formula. Formula for mass. M is equal to Q M. Okay, is this one not molar mass? It's supposed to be capital letter. It's molar mass now. It's supposed to be capital letter M. Okay, over NF Faraday. All right. So here we have quantity here, and we still have Faraday here. If you are using Faraday's first law of electrolysis to solve, there's no need to be putting Faraday. Okay, they hardly give you a question that is going to involve using that Faraday constant 96,500. No, it is hard. It is hard. We don't give you need to use this. So we are going to cancel this F out and we are going to use this one. Since the Q was represented in Faraday, let me show you. Look at it. Would be deposited by 8 Faraday of electricity. 8 Faraday. 8 Faraday. So this one is the quantity of electricity. Look at it. Quantity of electricity. Either it can be represented in what? Coulomb or in Faraday. So since this one was represented, the quantity was represented in Faraday, we are going to use this one. And we are going to overrule Faraday constant. We are not going to use this one. Okay. Now, this F now, no, we can't join. We don't cancel F. We can't be left with M is equal to Q molar mass over N. So now this one we'll use this solve now. So what are we going to do? Therefore, we can't do it in substitute. What is our Q? Q is 8 times. What's our molar mass? Molar mass of magnesium is what? Remember, if you are giving different elements, okay, they will give you all the molar mass of the elements, and you will have to calculate all the molar mass. You will plus all the molar mass. You do the complete molar mass of the compound. That one is common in chemistry. So we calculate all the complete molar mass. You sum everything up together to get the molar mass of the complete compound. Okay. So what is the molar mass of magnesium? 24. Okay. Over 2. All right. And if we simplify this times this, will give us 192 over 2. And this will give us what? If you divide 192 by 2, it will give us 96 grams. Okay, so this is our final answer. So 96 grams of magnesium will be discharged when you pass 8 Faraday of electricity through the electrolytic system. Now, let's look at the options. Among the options, pick the correct answer and drop it in the comment section. Let's look at the next question. Still under Faraday's law of electrolysis, Faraday's law of electrolysis using current and time. All right. We don't already do the first law. Okay. Now we want to use the same Faraday's law, but we are using current and time. Current and time inside the question. Now this kind of question JAMB they commonly set. So I want to fortify you completely. After this one, we are going to do the Faraday's second law of electrolysis. All right. So first of all, let's master this one because JAMB they repeat and well. So JAMB must repeat question 2. The question reads, in the calibration of an ammeter using Faraday's law of electrolysis, they indicated it. The ammeter reading is kept constant at 1.2 ampere. This one are the correct. Okay, more people write and for your giving, no need to the waste time. Okay, I, which is the current, is equal to 1.2 amperes. All right. Then if 0.990 gram of copper, so this one are the mass, okay, mass deposited, is deposited in 40 minutes. This one at the time. So the mass deposited is what? Mass of copper deposited, okay, is equal to, we'll put our mass of C is equal to 0.990 gram is deposited in 40 minutes. This one at the time. Time is equal to 40 minutes. Okay. The correction to be applied to the ammeter is what? So they are asking us what the correction is. Remember, we are calibrating an ammeter. Okay. So the correction to be applied to the ammeter is what? Question mark. All right. So now this one be waiting they give us. So now, what are we going to do here now? The same will find the correction where they need to make to this current. Remember, the current, now this current we want make correction to make we get the right calibration for the ammeter. All right, they gave us mass of copper deposited. Look at all the options provided. All the options now for ampere, meaning say all the options go in current. So we don't need to do too much for here. All right, so we go use the formula of the Faraday's first law, will be mass of an element is equal to ZIT. All right, where Z is what electrochemical equivalence you get in formula. I is equal to what current, T is equal to what time, M is equal to mass. Okay, since it be said that they ask us what the same will find, now this current will define I, now we define. We'll go rewrite this formula we'll rewrite them as I, we'll make I the subject of the formula. If we make I the subject of the formula, M will go up. Okay, I is equal to M over ZT. You understand that now? Okay. Okay. Now this formula we want to solve. Alright. So since we look for this I to get the correction to this current, looking at what we were given, they give us time here, see and here, T, time. They give us that one D. They give us mass, yes, see and here, see the mass discharge D. They give us Z, what is Z? Electrochemical equivalence. Okay, they give us electrochemical equivalence. No. They don't give us electrochemical equivalence. They don't give us. This I way they here, now the I way they give as the standard where we go use our I where we get take correct, take do the correction to know the correction where we need to apply, okay, to the current. So this one are like the standard where we say we go take do the correction. So we don't go need to use this I where they give us here now. We go use it later to calculate the correction, but not be now. We need to first get our own current before we come minus our current from the standard where they give us or the wrong one where we to get the correction for the ammeter. All right. So since we don't get Z, that one shows say JAMB want to make you go find this Z, which is electrochemical equivalence, and Z get formula Z electrochemical equivalence is equal to what? Is equal to that other formula of electrolysis. You make Z the subject of the formula. Z is equal to M over NF. F Faraday, N na number of mole. M na this M with it here now. Is M not the molar mass? Yes, M is the molar mass. All right. So that's that for that. So what we will come do next now to write out the ionic equation. Waiting happen where be say during the electrolysis of this copper. All right. So writing out the equation for copper. Okay, for copper. Cu, okay, Cu, okay, now 2 electron, okay, now be waiting valence electron copper, okay, plus copper loses 2 electron loss, okay, during the process, oxidation process, it loses 2 electron, to yield waiting copper metal, Cu, okay, this one is in solid state, okay, this one is ionic state, all right, so now 2 electrons, so this one now N, 2, now N, so our N now is equal to what? 2. Remember, saying that the valence electron will lose during the oxidation process for the electrolysis. So we don't get N now for here because they don't give us for here. Out of everything we want to solve this electrochemical equivalence, they don't even give us anything for here. Okay? They don't even give us Faraday constants. Now we go use the Faraday constant we will know for our head. Take put on here. Now we don't get N, it remains M and F. F now Faraday. And F now equal to Faraday constant equal to 96,500 coulomb per mole. Alright? So which other one we need again? We need what? We need molar mass. This one a capital letter or abego. No make mistake. Small letter for mass, capital letter for molar mass. Okay, so we need molar mass. What if the molar mass of copper? Molar mass of copper now waiting. Molar mass of copper is equal to subscript C is equal to my put on subscript Cu is equal to 63.5 gram. Okay, 63.5 gram. Is that a molar mass of copper? Yes, gram per mole. Okay, so since we don't get everything we need to solve for this electrochemical equivalence, now to solve for them now, we wait for no time. Okay, so if we want to solve for the electrochemical equivalence, we put everything here now. So substituting into this formula, Z is equal to waiting the molar mass, 63.5 over waiting be N now 2, say here 2 times Faraday 96,500, 96,500. Okay, so if we do waiting we get under here, it will be this times 2, we'll get 190 something thousand. Okay, so you use 63.5 divide 190 something thousand, you do one for calculator, you will get equal to 3.3. We are putting the answer in standard form times 10 raised to power minus 4 gram per watt coulomb. All right, so now this one now we get, so our electrochemical equivalence is not equal to this one. So this is our electrochemical equivalence. All right, so now time don't reach now we will use this time work because one go apply this formula because now this formula carry us enter this one chance to find only this Z, so now carry us go here. So we want come look at the time to use the time. All other units here they set, they okay, they good. But if you look at this time they in minutes, and the standard unit of time is second. Okay, and we have time in minutes. What we will do, we'll convert this time to wait in second. So converting time to second, T is equal to 40 minutes. Convert them to second, it will be 40 times 60 equal to waiting. 40 times 60 will give us 2,400 seconds. Okay, So now this one be the conversion of time. So now this one now we will use as the time. All right. So what we need to do now to calculate the current. Very easy. Calculate the current. So maybe we go calculate the current for the second page to make them look, make they bold, where maybe they see them clearly. Those say you see them now, but we'll go calculate them for the last side, make we clear. See what we need to calculate the current. We need what? Mass. We need what? Electrochemical equivalence we get for here already. And we also need waiting again. We also need time. All right. So we'll go to the other side. We'll solve for current. Calculate current. Okay. So calculating current, we're going to apply the formula. All right. So current is equal to M over ZT. Okay. Then if we substitute, we're going to get waiting be our M. The mass now, they give us mass of, remember, now 0.990. Now the mass they give us over waiting be Z 3.3 times 10 raised to power waiting will be 14. Sorry, 4 minus 4. Okay, times waiting be T 2,400 seconds. All right. So if you solve this down, you use this one times this one. Remember, I say this standard form now 0.000 0.00033. Now be this standard form. So if I want to convert this thing now, I want to put this thing for for decimal. It will be 0.00033. Okay, now it will come be times this one 2,400. Okay, if you times this one for calculator, it will give you 0.792. You can bring the numerator down. Okay, bring numerator down. It will come be 0.992. So we are now left with this. If you bring this one here now, 0.992 over 0.792. Sorry, this thing is supposed to be 90, not 92. 90. Okay, 90. All right. So if you divide this one by this, it will come give you. You will come get 1.25 equal to 1.25 equal to 1.25 if you divide this by this. Okay, 1.25 ampere. So now let's do the correction. Okay, doing the correction. Remember, I said the current where they give us for that question just now. See the current where they give us for that question. They gave us see the current 1.2 ampere. All right, and for there just now when we don't already solve our final answer now, we get 1.25 ampere. So to do the correction, it will be 1.20 minus 1.25. We minus old from new, not new from old. This one is the new current. So we will now minus the old current from the new current. 1.20. All right. So it will come give us equal to 0.05 ampere. Okay. So among the options, pick the correct option and drop it in the comment section. See you in the next class.